So let's start with the part 2 of analytical chemistry. In this, we'll be learning about the various reactions taking place, and we'll be learning about the products formed and what is the color and solubility of the product. Actually, we'll be talking about only the precipitates. Okay, so let's start with this. So first reactions, let's see the first reaction. In the first reaction we can see, so basically before continuing I would like to tell you all that in this chapter what we'll be doing, we'll be reacting the salts of colored ions like ferrous. What are the colored ions? I have told you all in the earlier video. Copper and all. Okay, all the colored ions salt. Okay, that means the salt is colorful. Okay, we'll react it by ammonium hydroxide NH4OH, or we'll react it by sodium hydroxide NaOH. Okay, इनको हम लोग react करेंगे and then we'll be seeing what is the type of precipitate formed. Okay, and then what we'll be doing in the precipitate, we'll be finding out the color of the precipitate and we'll be finding out the solubility. Okay, this is the, you know, the whole glimpse of the whole chapter, what this chapter is really meant for. Let's start with it. So salt can be what, which type of salts can be there? There can be nitrate salt, chloride salt, sulfate salt. So every type of salt possible we'll make. Okay, like let's talk about copper. So what we can make of copper? CuCl twice. Yes, then or what we can make? We can make CuSO4 also. We can also make CuNO3 whole twice. Yes, copper nitrate, cupric nitrate. Okay, so now tell me what will be the color of each of them. Tell me first, what will be the color?
Green, green,
Blue.
green.
No, the color will be blue because the
Blue,
copper
blue.
wire was blue. Yes, yes. Please remember the story and write it down in a separate page. Okay, because after 1 hour only you will forget the whole story. I just assure you that. Okay, because I have done the same thing with me. Okay, so let's start with the chapter. So first of all, we are taking the salts of iron. Okay, so iron sulfate, iron chloride. Okay, both of them are of iron. Then we react it by sodium hydroxide and ammonium hydroxide, as I have already told you all. Okay, what we are getting in the product? See, both the irons are different. In this iron we are having what? We are having Fe2 plus, and in this we are having Fe3 plus, isn't it? Yes, because the valency of sulfate is also 2 and valency of iron is also 2. Therefore, they are getting cancelled and we are not showing them. Okay, and in this, chloride is having 3. Yes, that means it must have crossed multiplied. That means ferric is having valency 3. So what do we come? What is the conclusion of the whole thing? The conclusion is that this one is Fe2 plus and this is Fe3 plus. Okay, I hope this is clear to everybody. Now let's move on. Let's see what's happening in the reactions. So what will happen? First of all, let's see. We'll get the hydroxide as the precipitate. In every example you can see the hydroxide, isn't it? Every example, just take a look, we are getting a hydroxide. So in this we'll get HOH whole twice because the valence is 2. Yes or no? Everybody must be knowing Fe2 and OH1 will cross multiply. OH minus and Fe2 plus both will cross multiply and we'll get FeOH whole twice. Like this the reaction is happening. In the second one I will not tell you what's happening because you yourself know what's happening, right? Yes or no? So let's now begin. So see what's happening. We will get FeOH whole twice, and in that we are getting FeOH whole thrice. So we all know that Fe2 plus is having which color? Two parts were colored with what? Green color, isn't it? Yes or no? Tell me first. Yes?
Yes.
Yeah. And let's talk about Fe3 plus. Fe3 plus was brown, yellowish brown. Okay. So we have got this dirty green precipitate, and in this we are getting a, I have not written it here, write it. It's giving us reddish brown precipitate. Okay, reddish brown precipitate. Now we'll now react it by excess of NaOH, means excessive extra NaOH. We'll add NaOH and NH4OH, that is sodium hydroxide and ammonium hydroxide. What will they give us? They will still be insoluble because they are precipitate. You all can see it's insoluble. They will still be insoluble. They will still be dirty green. That means, what is the conclusion? No change. Yes or no? No change is taking place. We are moving on to the second reaction. What was happening in that? We were having X, and now let's do excess of NH4OH and NaOH. Okay, that is sodium hydroxide and ammonium hydroxide. What we are getting? We are still getting the reddish brown insoluble because it was already insoluble, because it is a precipitate. Okay, so it's an insoluble precipitate. Here also, what's happening? Nothing is happening. No change in excess. Okay, no change in excess. Let's move on to the third one, that is copper sulfate. What is happening in copper sulfate? Copper sulfate will give its hydroxide. As I've already told you, in every example we are getting a hydroxide. So just give me a minute, I'll just do it. Yeah, so we have got the hydroxide of copper, as you all can see here. Yes, and what else we got? It is also insoluble because it's a precipitate. Copper was of which color? Copper was of blue color. And here what we are getting? We are getting pale blue. Some colors get altered, like green turned to dirty green. Okay, so we are getting a hydroxide of everything, and the color is getting altered again and again. Yes, green is turning to dirty green, brown is turning to reddish brown, blue is turning to pale blue, because of this NH4OH and NaOH in between, because they are doing what? They are reacting with the original color and they are altering or changing the color. Okay, now it is pale blue now, and it's insoluble just now. Okay, let's see what happens in excess. So when we do it in excess of NaOH, then what we are getting? We are getting pale blue insoluble. This is NaOH, please keep that in mind. It's sodium hydroxide. It's insoluble in plain blue, pale blue. It's unchanged. That means here what's happening? No changes taking place. Okay, let's talk about excess of NH4OH. Here we talked about NaOH. Now let's talk about NH4OH. What is happening? It's now soluble, deep blue, inky blue. Oh my god, it has changed. So here we'll write it has changed. Understood? Is this clear up till now? Let's move on to the next one, that is lead. So lead is of which color? It's colorless or white. See, colorless or white is very different. We can't say that you are colorless and white as well, but let's just believe what's written here. Let's just think it's colorless as well as white, because in most of the book it's written white and in some it's written colorless. Okay, so colorless and white lead nitrate will react with NaOH and NH4OH to give us the hydroxide of its. Okay, we got the hydroxide. See, we got the hydroxide just now, right? And then what we'll get, if we add them in excess, if we add NH4OH in excess, we are getting insoluble chalky white. The same thing here, it turns chalky white. It's the same. So here we'll write it's no change here. Yes, no changes happened. Now if we add it in excess, NaOH, NH4OH में तो कोई change नहीं आया. अब NaOH में देखते हैं, सोडियम हाइड्रोक्साइड में. What happened in sodium hydroxide? Soluble बन गया वो, और उसका कलरलेस सोल्यूशन बन गया, मतलब अब ये चॉकी वाइट से कलरलेस सोल्यूशन बन गया, एंड दिस इज अ बिग चेंज, बिग डील. सो दिस इज, here we'll write changed. Okay, you are changed. Let's move on to the second last, because one more is there after this slide. So see, Zn4OH, that means zinc sulfate. Have we learned the color of zinc? No, we haven't, but we have to mark this up, that its color is not mentioned just now. It's colorless or white. In most of the book it's written white. Okay, so now see what will happen. What will happen? It will react with NaOH and NH4OH to give us a gelatinous white precipitate. It's insoluble. Okay, gelatinous white means a jelly like white precipitate. Okay, a jelly, slimy. You must have already seen a slime, so it's very similar to a slime, a white slime. Okay, now let's move on to the excess thing. So when we add it in excess, what we are getting? We are getting a soluble colorless precipitate. Okay, no, it's not a precipitate because it's soluble. Such a big blunder I've done just now. It's not a precipitate, it's soluble colorless product. Okay, let's move on to the next slide, in which we'll be talking about the last element, that is calcium. Do you know the color of calcium? Because you must be knowing that milk contains calcium. Yes or no? Milk has got what? Milk has got calcium in it.
Calcium.
And milk is of what color? Milk is of white
White.
color. So calcium will also be of white color. You can remember it like that. So calcium salt, if you take CaNO3 whole twice, what we'll get? See, it's very easy. You must be thinking, what is this NO3 whole twice? It's so hectic. See, Ca is having 2 plus valency and NO is having NO3 minus 1. Okay, they both will cross multiply.
Crisscross.
You must have read this and all. Yeah, crisscross and whole twice like this. It's okay. So no need to panic. It's all fine. Okay. Now, next we move on to this calcium one. So calcium nitrate. Then when we add NaOH, it turns into calcium hydroxide, and it is white. The same thing which I told here. Okay, and it's sparingly soluble. Sparingly means it's almost soluble. Almost means it's almost insoluble. That means it's mixing, but at the same time some precipitate is also there. Like if I give you an example of chalk, what happens in chalk? We mix the chalk, what happens? The water changes white after some time, but at the same time a large amount of insoluble chalk particles get settled under the water, isn't it? On the bottom of the vessel, isn't it? So that's the thing we are talking here also. Okay, so it's sparingly means it's little soluble. Okay, next we move on to excess of NaOH. Just now we are not talking about NH4OH because nothing takes place, no reaction takes place. See, NH4OH excess, if we do, what happens? White insoluble thing we get. That means what we are getting? We are getting the same thing, no change. Right here, no, this was done. Why NH4OH is not showing any reaction? Why is there no reaction? Okay, why is there no? See, 4OH is a not having hydroxide to or displace NO3 whole twice, which is there in from the calcium. So I hope everybody has copied up till now. Let's move on to the next slide. This is the last part of the whole topic. After this, we are completed with the chapter. Let's finish this also. So now we'll see the action of alkalis. Okay, what are alkalis? Alkalis are the bases which are soluble in water. Everybody must be knowing. Everybody must have what should I say? Everybody must have rectified a word also, that all alkalis are bases, but all bases are not alkalis, isn't it? So we all know that it's a base. NaOH, KOH are some examples. Okay. So on if we, now we'll see the action of these alkalis on certain metals and their oxides and hydroxides. So let's see first of all on metals. So what happens when we react any alkali with metals? So when a metal plus alkali is happening and this alkali is hot and concentrated, okay, what will happen? We are getting what? We are getting a salt and hydrogen gas. Are you understanding? And this salt is soluble in nature. Okay, let me give you an example. Let's see the example of aluminium. So you all can see the example of aluminium. Aluminium is reacting with an alkali, that is NaOH. Yes, plus water. We give it some water because there will be no reaction because they both are dry. We give them water. What happens? We get NaAlO2, that is sodium aluminate. Okay, sodium aluminate plus hydrogen gas. And this sodium aluminate is not a precipitate. Don't do the mistake of making this precipitate sign. You will get a 0 out of all the things. Okay, so this is sodium aluminate. Now see, if I take all the oxides and hydroxides, like I've said in the heading, if I take the oxides and hydroxides of these metals like aluminium, zinc, lead, etc. See, aluminium is there in your syllabus, zinc and lead have been removed. Okay, other recording. So see, what will happen when the oxide and hydroxide of aluminium, zinc and lead, like what will be the hydroxide and oxides? Let's talk about the oxide of aluminium. As you all can see, I've already written the oxide of aluminium is Al2O3. Yes, it's sodium, it's aluminium oxide. Okay, hydroxide, if we talk about of aluminium, it's AlOH whole thrice, that is aluminium hydroxide. If I talk about the oxide of zinc, ZNO, that is zinc oxide. Hydroxide is ZNOH, zinc hydroxide. Okay, oxides and hydroxides, you can just make it yourself if you have not ever read the name. Then also, if you know the valency, just cross multiply and you have your oxides or hydroxides. Okay, they are what? They are amphoteric in nature. They are what? They are amphoteric nature. Please remember this word. What is amphoteric? Amphoteric is a type of substance which reacts or behaves as acids as well as base. Are you all understanding? What will happen? Now, we all know that acid plus base gives salt and water, isn't it? But if we add an amphoteric substance to a base, then also it will give us salt plus water. Means amphoteric is behaving like acid. Yes. Now if I remove this base from here and if I react it with an acid, then also it will give us salt and water. That means it's reacting as a base also, isn't it? Is it clear up till now? See, it's such a colorful slide. Yes, that draws your attention towards it and you are recalling everything very nicely. So that's what I've written here, that when we react an amphoteric oxide or hydroxide with acid or base, we get salt and water. Okay, let's take the example of aluminium. Aluminium oxide is Al2O3. We react it by the base. What will happen? We get sodium aluminate plus water. Okay, a salt and water neutralization reaction. AlO3OH whole thrice. Please don't confuse it with neutralization reaction because it's not an acid reacting with the base. It's an amphoteric oxide or amphoteric hydroxide. It's not neutralization reaction. Okay. Now let's take the hydroxide of aluminium. We reacted by NaOH. What we'll get? We'll get sodium. What we'll get? Sodium aluminate, and that too. No, it's sodium meta-aluminate. Okay, and we'll get water. I'll write the name also just now. Give me a minute. Yeah. So let's write the name. This is sodium meta-aluminate. Okay, and this is what? Sodium aluminate. I've already written. Okay. Okay. Now let's see what happens with lead and lead oxide, lead hydroxide, and zinc oxide and zinc hydroxide. I've not mentioned that in this slide because I thought that it's not anymore in the syllabus, but let's discuss it anyways. So first, let's come to zinc. Okay, so zinc oxide will be what? ZnO. Yes, zinc hydroxide will be what? ZnOH whole twice. Yes, when we reacted by any base, let's take the base. I'll give you one example only. Okay, just give me a minute. Yeah, so let's take a base. Which one would you like to take?
NaOH.
Let's take KOH. Okay, Rajat, let's once take KOH. So what will happen? So let's take the base KOH. Okay, so we are taking KOH now. Yeah, so when we reacted by KOH, what all we get? First of all, here we get K2ZnO2. That is potassium zincate plus water. And here we get, again we get potassium zincate, that is K2ZnO2. Okay, K2ZnO2 plus water. See, so we are getting the same products every time. So let's write the name. This is what? This is potassium zincate. Okay, let's see another example of the same thing, zinc only. Let's take zinc oxide again and zinc hydroxide again. Okay, and react it by NaOH instead. Okay, now what we'll get? We'll get Na2ZnO2. The same thing. What we got here. Here, just write Na2. Okay, everything else will be the same. So write Na2ZnO2 plus water, and here also we'll get Na2ZnO2 plus water. Okay, and what is the name of this? This was potassium zincate. This must be what? We have sodium instead of potassium, so this must be sodium zincate. Sodium zincate. Is it clear? Let's move on to the next thing. So next we'll talk about lead oxide. Okay, lead is what? Lead is Pb. So lead oxide. Okay, plus let's take one base only this time. Let's take the base NaOH now, Rajat's favorite. NaOH. NaOH will give us what? Na2PbO2. Same thing in everything. Okay, same. So all the products will be the same, okay, when we reacted by NaOH. Let's take KOH for example now, okay. Okay, just yeah, let's take KOH in example now. Instead of NaOH, let's take KOH. What we'll get in KOH? We'll get, this is PbOH whole twice, if for coin information. This is KOH. We'll get K2 PbO2 plus H2O. K2 PbO2 plus H2O. You must be thinking, how will I remember these big names? See, everything is same in every reaction. Na2 PbO2, same. Na is now not there. Potassium has come in its place, so it will be Pb. Potassium will come in its place. Okay, I hope that it's clear now. So let's now write it. This is what this is: potassium plumbate. Okay, now that was all for this chapter. We are done with the chapter. Every question you will be able to do. That's all for today's class. Thank you for watching my video. Please like, share, and subscribe to my channel.